In this video, we're going to talk about prime factorization on the TI-34 MultiView calculator. Okay, so before we do prime factorization, let's talk about prime numbers very quickly. You need to know that prime numbers start with 2, then 3, 5, 7, 11, 13, 17, 19, 23, and it goes on. Okay. We don't know exactly where it ends, but the only even prime number is 2. Everything else is odd. So what's so special about prime numbers? Prime numbers are divisible by themselves and 2 only. They don't have other factors that break down these numbers. Like, for example, 6 can be broken down into 2 times 3, which, by the way, are prime numbers. This 6 is called a composite number. So let's say we have 10. Can we break it down into prime factorizations? And the other question maybe is, why would you? And we'll figure that out. So it ends in 0. So we know that 2 goes into 10. 10 divided by 2. Enter 5 times. So we know that 10 is equal to 2 times 5. So 10 is a composite number broken down into primes. What about 50? Let's see. It ends with 0, so we can say 2 goes into 50, right? 50 divided by 2 gives you 25. Can we break down 25? Yes, because 5 will go into 25. How many times? We can just press divide. It grabs the previous answer, and then we just say divide by 5, enter. It gives you another 5. So 50 is really 2 times 5 times 5. But we like to write shortcuts. 2 times 5 squared. That 5 squared represents 2 5s. Now, in class, maybe you do a tree thing where you get 50, then you say 2 times 25, and then 5 times 5, and then you move like that to find it. I don't like the tree method. This is a little bit cleaner because at the end, when you do all this, you should end up with a prime number. Okay. Let's try 350. It ends with 0. Oh, good. So 350 divided by 2, enter, 175. Okay. It ends with 5, so we know that 5 will go into it. Divided by, I just have to say divided by 5. Enter, 35. Another 5, oh, okay. 5. 5 goes into 35, right? Divide by 5, 7. And you probably already know this through your multiplication tables. But if you don't, this is why you have the calculator. 350 equals 2 times 3. Nope, sorry. I don't know why I want to write 3s. Let's write that again. 350 equals 2 times 5 squared times 7. Now, let's talk about prime factorizations. Why would you want to use them? Let's say you had 50 divided by 350, right? Okay. We can break down 50 into 2 times 5 times 5, and 350 can be broken down into 2 times 5 times 5 times 7, right? We can see that we can cancel, cancel, cancel. That's a 1. So that's 1 over 7. So 350 divided by 350 can be broken down into 1 over 7. So this has a fraction button. Let's use it. Fraction button. 50. Move down. 350. Enter. Yes, this one has a simplification and has an arrow. So simplify answer equals 25 over 175. It took away the 2 here. So that's 25 over 175. Look at that. And if I cancel this, simplify even more, I get 5 over 35. Let's see. Simplify. Enter. Yep. 5 over 35. And then simplify. Enter. 1 over 7. Okay. There it is. There's the answer. So utilizing prime factorization can easily reduce your fractions. Don't forget, fractions are your friends. If you like this content, Please give it a thumbs up. Please subscribe. Please tell your friends. You know, there's more things in this channel if you want to look. All right, let's do something like 101. Okay. Now, 101, this is a little bit harder. You know, this is not a 2 or an 8 or something. It doesn't end up with an even number. So most likely 2 won't go into 101. So if you do 101 divided by 2, it doesn't go evenly. What about 3 divided by, let's clear that. 101 divided by 3, that doesn't go into it. How about 101 divided by 5? I know that won't go into it because it doesn't end in 5. 101 divided by 7, that doesn't go into it either. How far should we go? Right? It turns out that 101 is a prime number. We don't know how many prime numbers there are today, but we do know that 101 is a prime number. Question is, most likely you didn't know that. So how far should we go in this list to say, okay, we can stop there? Well, we can take 101 and take the square root of it. Okay? Take the square root of 101. We enter it. That gives you 10.0498, which, if you round up to the next prime number, is 11. So we can go up to 11. We can use 2, 3, 5, 7, 11. Okay? And if we look at the calculations we've done so far, 101 divided by 7, right, doesn't cut it. So 101 divided by 11 doesn't either. Okay? And you can do 13 if you wanted to. Doesn't. Or 17. But why would you? If you already know that the cutoff point is 11. Okay? So this is a prime number. It can't be broken down into prime numbers, and this is this is not a composite. Let's try one more, 51. Some of you might say, 51. 51 is prime, right? Well, there's a trick that you can do here. And this is one of those tricks. You can add the numbers, the digits. 5 plus 1 is 6. Is 3 divisible into 6? Yes. Does 3 go into 6? Yes. So 51 is divisible by 3. Okay? It's not divisible by 2. 51 divided by what? 3 equals 17. Turns out that 51 is 3 times 17. So just because it looks like it's prime, don't stop, right? Because if you took 51, took the square root of 51, right? 51, square root of 51, enter, right, is 7.14, right? The next prime number is 11. You could have used 2, 3, 5, 7, 11, right? 2, 3, 5, 7, 11. And if you went to 11 and 11 didn't go into 51, then you would stop, right? 51 divided by 2. We know that doesn't go into it. 51 divided by 3. It does. Okay. And 17 is a prime number right here. So we stop. I know that was a little bit fast. All you need to do is rewind the video and then go over it again and again and again. Somehow it will go into your mind how to do these problems. It's not easy, but it's very feasible. Okay? So I hope you tell your teacher, your friends, your schoolmates, please subscribe. Please give it a thumbs up if you like it. I really appreciate you watching the video. I hope you have a great semester. I'll see you later. Bye-bye.